that plays the thing with your host, Judy Sleed. Special guest, Timo Stein, Cosmologist. Now here's Judy.
Thank you, everyone, again. And I have Timo here with me, who is a little genius. I mean, he's very tall, but he's very young. And he's going to talk to us about NASA. And he's going to inform us it's not just a takeoff to the moon, but it has other functions.
Yeah, thank you for having me. Thank you for having me the second time, indeed. And the last time I saw you, it was before the time I went to NASA and worked this summer on cosmology. And what I would like to do is share some insights and also a little bit talk about the general issue of astronomy and why it is important, why it is interesting for the public as well.
Yes, we would all like to know what goes on there, so enlighten us.
Well, first of all, you said something in the beginning about NASA. Yes, indeed, they have not only sent man to the moon, but NASA is doing much more. And what I have experienced here in the States is that many people don't know what NASA is really doing for them.
That's so true.
So I ask you straight ahead, what do you think is NASA doing for you?
What is it doing for me? I wish I would know. I thought it was just they're selling tickets to the moon. No.
They're selling tickets? I haven't heard that yet, but I'm interested. I'm going to get some. Well, I can give you one big example.
Yes.
And that is if you look up the weather report and the weather forecast. The images you can see were taken by NASA satellites in cooperation with NOAA, the National Oceanographic and Atmosphere Administration. And so NASA is very important for all of us. And it's not only doing like science, understanding things like our sun. I've got some gifts from NASA here. This is, for example, our sun. So NASA does research not only in parts of astronomy, such as the sun, or the universe as an entity, like this ball here, showing the so-called cosmic microwave background radiation, but also it does provide the weather forecast for tomorrow.
That is good. Yes, so I never knew that when I listened to the weather, that it comes from NASA. So I'm glad that, but according to you, it does a lot more things, like something about what goes on in the universe. That's
correct. And this is not only a balloon or something you can play with on a beach, but this is pretty much a picture of the fingerprint of the universe, the echo of a Big Bang. And in my first show here with you, I was talking about this topic, the cosmic microwave background radiation.
Yes.
So what NASA does, it sends multiple satellites into space in order to take this picture, because from Earth, we cannot see this. What you can see here is a temperature difference all across the sky, as small as only 1,000th to 1,000,000th of Fahrenheit or Kelvin.
And those different colors mean different temperatures?
Yes, they do mean different temperatures. And what we can see here in the middle, the red band, that is our galaxy. That is the harbor of our life, the so-called Milky Way. So what is in particular interesting is NASA tries to answer the question, what is our place in the universe and where did we come from?
Where we came from,
yes.
Yes. Well, did NASA figure out where we came from?
Well, everything started in the Big Bang. That's something we all know by now. Yeah. And the picture of the Big Bang is encoded in that ball, basically. But what it shows is basically that in the early universe, the universe wasn't perfect. It was not plain white, as you would say. It has little dots of gray color, for example. And that means that mass, of which we are all made of, was not uniform distributed in the universe. So what happened is, what we can see here, these red and blue spots, they show areas in the young universe where mass was a little bit denser and a little bit less dense in other places. And that caused something to happen. We all know we stand on Earth. That's because Earth is pulling us down.
Yes.
The force acting is called gravity.
Right.
Isaac Newton discovered it a couple of 100 years ago as the apple was falling on his head. And we would like to understand a little bit more gravity. But the effects of gravity are obvious for all of us. So in the early universe, what happened is that the gas, the mass, got concentrated at big, huge clouds. And these clouds later on formed the very first stars, like our sun, but much bigger. And these stars created the mass and the stuff we are made of. Because
when you say we are made of humans,
everything around us, we are like waste material of former stars. Because in the very early universe, you only had hydrogen and helium. And you know, it is gas. It's not solid like we are. So over the past 13.7 billion years, that's the age of the universe, which is pretty old.
My gosh, I can't even imagine how you figured it out.
Again, it lies in the fingerprint of the universe, in that little tiny ball. And through analyzing that ball, basically, we were able to get the age of the universe. But let's get back to why stars, the very first stars, are so important for us. But the first stars, they created elements beyond helium and lithium and, of course, hydrogen. They created oxygen, they created carbon, silicon, and everything else till uranium. And that's what we are made of. So without these very first stars caused by these little dots on that ball, we weren't here. The universe would just be a big balloon made of gas, basically. Nothing special. So I also brought you something here from NASA.
Yes.
A few posters.
Posters, yes.
And I would like to show you something, talking about stars. So let's go to the very first poster.
Okay. And this is a picture of
a star. It's the birth of a star. And this picture was taken by a NASA ESA satellite called Hubble. And the Hubble Space Telescope is one of the biggest missions NASA ever accomplished. It's a huge telescope flying in space in order to take brilliant pictures, which we weren't able to take on Earth. So this is one of the pictures we have, if we switch back. It's called the Eagle Nebula. And what we see here is a big cloud made of gas. And it's light years in size. So the light traveling from one side to the other takes a couple of years. So if you have a little flashlight, it takes a couple of years till the person on the other side could see it. But also in there, the dark spots is dust. And that dust hides something beautiful. It's the birth of stars. And that cloud you can see, there are new stars created, like our sun was created about 5 billion years ago. And what you can see around it, the light, is caused by these young stars because they are so hot and so dense that they let glow the environment. And we can see that glow with the Hubble Space Telescope.
That's amazing. And at NASA, they teach all this to young people?
Yes, NASA has a lot of opportunities for young people, not for people as young as I am, like in high school, because not a lot of people do something in that field of cosmology and astrophysics, but especially for students. And I have had the opportunity to share my time with people of the program called NASA Academy, which are 20 people across the United States. 3 of them were selected by the European Space Agency, and they all come together and work for the entire summer at NASA. And I worked with them at Goddard Space Flight Center, and I worked on that little ball basically. I helped to develop a new instrument which was able to get an even clearer view on the CMB in order to conquer new quests in science, basically.
So can we learn about the other poster?
Yes, we can, because first of all, what we have seen before was the birth of stars.
The birth of stars.
So we have stars now, and they are shining. Beautiful.
Yes.
They create new elements. So it's basically like our sun, but somehow they use their fuel. And if you run out of fuel, you get in trouble. And the same thing happens to stars, even to our sun. So after a couple of billion years, a star explodes, just ends its life. That's what we can see in the next poster, if we switch. And what we can see here is a star in its late age, and it's starting to release the new created elements to outer space. And that's what we can see here. We see the red star here, which is right about dying, and it has emitted this gas cloud. And it acts like a mirror, because the light being emitted by the star is reflected off that gas cloud. And we can see that light echo up here. This is also a picture taken by the Hubble Space Telescope. So we are made of the stuff which we can see around this red star. That's basically us. That material.
Is us, you said?
That's us. That's us. And our sun is a second generation star. So it got the material of a former star. Our planet was formed, and life has been created. We don't understand why life got to this planet. We don't know it yet. That's one of the quests science has to conquer yet. But that's basically a start. Without stars, we weren't here. And also our sun, our star, is powering us, supplying us with energy, and with beautiful sunsets here in the Hamptons as well.